Bismillahirrahmanirrahim. Okay, so this is the second part of this chapter 7, okay, in which chapter 7 is about the intermolecular forces between molecules. So this second part is the relationship between the intermolecular forces trying to the physical properties of the liquid. Okay, so let's look at the first physical properties of the liquid, okay, which is the volume and the shape. So we know that the liquid has a definite volume. Okay, the volume of the liquid is definite. If let's say we measure 20 ml of the water, we transfer it into a jug or we transfer it into a glass, it still have a 20 ml of volume. But the liquid has no definite shape, and it will follow the shape of the container. The second properties of the liquid is about the compressibility. Okay, so the liquid particles are packed closely together and they have a very little empty space. So due to that, the liquid are more difficult to be compressed as compared to the gas. But if we compare the compressibility of the liquid and solid, of course that it is still can be compressed as compared to the solid. The third properties is the surface tension. Okay, so the surface tension is the amount of energy that is required to stretch the surface area of the liquid, or it is the amount of energy that is required to increase the surface area of the liquid. Okay, so this is because when we have a liquid sample, the liquid will experience the intermolecular forces attraction from all directions by the neighbors molecules. This is what we have learned before. The intermolecular forces will mix all particles, all liquid particles attracted to the neighbors. If we look at to this figure, we observe that there are two types of the liquid particles. The one on the surface of a liquid, we call them as the surface particles, and below them they are all inner particles. So all these particles being attracted with each other because they are having intermolecular forces. So if we have these particles, inner particles, it will be attracted, it will be experience the attraction upward, and sideways, and also downward. However, for the particles that are at the surface or surface particles, they will experience attraction only to sideways and downward. It means that the surface particles is actually being pulled into the liquid. That is why the surface will have a fewest particles. Then it will make the surface area of the liquid become the smallest, as possible, because only the particles that can overcome the IMF, the attraction into the particles that will remain as the surface particles. That is why when we define the surface tension, it is actually the energy that is required to increase the surface area. So how to increase the surface area? By breaking all the intermolecular forces. So these intermolecular forces will pull the molecules into the liquid and it will make the surface of the liquid to be stretched and tightened. The liquid surface will have the fewest particles and the smallest area as possible, and it will make the surface of the liquid like to have a taut skin. And what is the relationship between the surface tension and the intermolecular forces? So the relationship is directly proportional. When we have a stronger intermolecular forces, surface tension also higher or greater. This is the example of the surface tension phenomenon. And the first one is the beading of the rainwater on the surface of the automobile. If let's say we look at to the rainwater, they are in a bead form. This is actually due to the surface tension when the surface particles being attracted into the liquid. It makes the water droplet like a bead. And then the second example of the phenomenon is the water striders that can stand on the surface of the pond. And we also can observe that if we have a paper clip, it can float on the water. The fourth properties of the liquid is the vaporization. When the liquid vaporizes, or the volatility of the liquid. So this vaporization is actually the process in which the molecule escape from the liquid into gas through the surface of the liquid. Okay, the liquid is transformed into gas through the surface. Okay, this is the vaporization process. Okay, when a liquid is vaporized is when they have enough energy. Okay, when their kinetic energy is sufficient enough so that they can overcome the attraction force between them. Okay, it will make the molecules loosen themselves and then they will escape and they will be evaporated off. That is the vaporization process, how the liquid turns to gas in through the surface of the liquid. So the vaporization rate depends on three factors. Okay, the first factor is the surface area. So if we have a larger surface area, if let's say we have 20 ml of water that we put into a glass and also into the pan, of course that pan will have a greater surface area, so that the one that have a greater surface area will give the higher chance for the molecules to escape from the surface because we have more or extra surface particles. Okay, therefore the relationship is when the surface area increases, the vaporization rate or the evaporation rate will increase. Vaporization is the same as the evaporation. Okay, the second factor that will affect how fast the vaporization occur is the temperature. So if let's say we compare between a glass of water that we put into a chiller with a glass of water that we put outside the house, okay, under the sun, of course that the one that outside the house will be vaporized faster as compared to the one that is in the chiller. Okay, this is because when the temperature increase, the total number of the molecules with the high kinetic energy will also increase, and we know that when they have enough energy, then they will overcome the intermolecular forces and they will escape from the surface of the liquid and vaporize. So the relationship is the higher the temperature, the faster the rate of the vaporization. Okay, and then the third factor that determines the rate of the vaporization is the intermolecular forces. So if let's say we have two different liquid, okay, A is a liquid that have a stronger intermolecular forces and B is a liquid that have a weaker intermolecular forces, then we will observe that the one that have a weaker IMF will vaporize faster. Okay, because it is easier for them to overcome the attraction with the neighbors. Next property is the vapor pressure. So the vapor pressure is defined as the pressure exerted by the vapor molecules at the equilibrium with its liquid in a closed system. Okay, pressure exerted by the vapor molecules at the equilibrium with its liquid in a closed system. Okay, so let's look at to what happens when a liquid vaporizes. We know that when the surface particles have enough energy, then they will vaporize, turns to the gaseous particles. Okay, from time to time, then we will have more gaseous particles that is formed. Okay, and we know the behavior of the gas particles, they always collide each other. So during the collision, some of them might lose their kinetic energy, then they will not be able to remain as a gas, so that they will come back and being trapped and turn back as a liquid particles. Okay, so initially what is happened when they turns to a gases, okay, is a vaporization, so that when they return back and turns back to liquid, they are undergo condensation. Okay, so if let's say this system is a closed system, this is happen in a closed vessel. So they will reach one time when the rate of the vaporization is equal to the rate of the condensation. Okay, so at this time when we measure the pressure in that closed system, okay, and that pressure is what we call as the vapor pressure. Okay, in which pressure that is exerted by the vapor molecules. Of course that the vapor is, when we talk about pressure, okay, it is about the pressure exerted by the vapor, okay, above the surface of the liquid. Okay, when the system is at the equilibrium in which the rate of the vaporization at that time is equal to the rate of the condensation. So what is the difference between vaporization and boiling? Okay, so we have discussed just now the vaporization is the process of changing a state of the liquid into vapor that is occurred through the surface of the liquid, and it is actually happen at any temperature and pressure. If we compare it with the boiling process, okay, it is the change of a state of the liquid into the vapor. Okay, they say the similarity of these two, liquid turns to vapor. Okay, but it is occur to the inner and also the surface of the liquid, and it is also happen at the certain temperature. Okay, and this certain temperature is actually when the vapor pressure of the liquid is equal to the external atmospheric pressure, and this temperature is what we call as the boiling point. Okay, so let's look at to the 6 properties. What is the definition of the boiling point? It is actually defined as the temperature at which the vapor pressure of the liquid is equal to the external atmospheric pressure. Okay, temperature when the vapor pressure is equal to the atmospheric pressure. Remember, we have discussed vapor pressure just now. Vapor pressure is the pressure above the surface of the liquid. Okay, when the rate of the vaporization is equal to the rate of the condensation. So that when the vapor pressure is equal to external atmospheric pressure, then the liquid will start to boil. Okay, and if we measure the temperature at that time, this is what we call as the boiling point. Okay, so this boiling is a process of changes from liquid to gas that is occur to the surface and inner parts of the liquid. Okay, and during this boiling, okay, we will observe the bubbles, okay, of the liquid. If we continuously supply heat to the liquid that has boiled, then we will observe that the temperature remain the same. Okay, and this boiling occur at the specific temperature and pressure. And of course that the boiling point is depends on the intermolecular forces. So if you have a liquid that have a weaker intermolecular forces, the boiling point also lower. But for the molecules that have a stronger IMF or stronger intermolecular forces, the boiling point of that molecules will increase. Now, what is the normal boiling point? Okay, there are two different definition between the boiling point and the normal boiling point. Okay, so normal boiling point is the boiling point of the liquid at the standard pressure. Okay, so what is the standard pressure? What is the pressure here? Okay, at the normal elevation, okay, it is 1 atm. So that when we boil a liquid at 1 atm, when the external pressure is 1 atm, and the temperature at that time is what we call as the normal boiling point. Okay, so if we have to define normal boiling point, we just need to add another one point at the back. Okay, normal boiling point is defined as the temperature at which the vapor pressure of the liquid is equal to the external atmospheric pressure at 1 atm. Okay, that is the normal boiling point. And this is the last properties of the liquid that we want to discuss, which is the viscosity. Okay, so viscosity is actually the resistance of the fluid to flow. Okay, whether it is easy for the liquid to flow or it is hard for the liquid to flow. Okay, viscosity or kelikatan. Okay, so this viscosity is actually results from the strength from the intermolecular forces that impede or limit the movement of the molecules around and pass over each other. Okay, and if of course that if we compare the viscosity of the gas and liquid, liquid will be more viscous. Okay, gas will have a lower viscosity as compared to liquid. Liquid is more viscous. Okay, and then there are two factors that influence the viscosity of the liquid. The first one is the temperature. Second is the intermolecular forces. If let's say we have an oil, okay, we have a hot oil and room temperature oil. Okay, we compare their viscosity, then we'll observe that the hot temperature of the oil will be less viscous. Okay, it will have a lower viscosity. Then those at the room temperature will be more viscous or have a higher viscosity. Okay, so the higher the temperature, the lower the viscosity. And then the second factor that influences the viscosity is the intermolecular forces. Okay, if we have a liquid that have a stronger intermolecular forces, it will make the molecules become more viscose or have a higher viscosity, because when the particles have a stronger intermolecular forces, it will make the particles to be harder to pass over each other. Okay, when it is harder for them to pass over each other, then they will become more viscose. Okay, so the relationship between temperature and viscosity is inversely proportional. The higher the temperature, the lower the viscosity. As for the intermolecular forces, they are directly proportional. When we have a stronger intermolecular forces, then the viscosity also higher. Okay, so that's all 7 properties of the liquid that we want to discuss.